Okay, this is a quick revision of static electricity. I'm not going to go through it in too much detail, but this is sort of the bare bones of it. Metals. Metals are very good conductors of electricity, and the reason for that is because the electrons can leave the atoms and move through. So if a charge moves through, if you get a voltage through a conductor, the electrons can move through. So they don't tend to build up. The charges don't tend to stick around in a conductor. They tend to move away pretty rapidly. But in an insulator like rubber or plastic or something like that, the charges don't want to move. They want to stay put. The electrons or charges want to stay where they are, because in an insulator they can't move through. So something like this comb, you can see that the charges are built up. There's a negative charge in there, and that charge has stuck those pieces of paper to the comb. Now, static, what does static mean? Well, it means still. It means the charge isn't going anywhere, it's hanging around. So how does this happen then? Well, as a bit of revision, you've seen this before. In an atom, the nucleus, the middle part of the atom, is positively charged, and around the outside you've got these things called electrons, which are negatively charged. And when I'm talking to you about this stuff, I'm using the word electron and the word charge interchangeably. They're the same thing. It's just this little negative thing that can move around. So if I do something like rub a polythene rod with a cloth, what can happen is those charges or electrons, those negative charges, can move from the dry cloth over to the polythene rod. The pluses can't move. The nucleus of an atom is a big thing compared to the electrons, and they can't move, they stay put. But you can appreciate that if the dry cloth loses its electrons, it's going to become overall plus charge, and if the polythene rod gains more electrons, then overall that's going to become negatively charged. And because a polythene rod is a good insulator, those negatives stay put. They don't go flowing away through the material. You've seen the Van de Graaff generator working. That's basically, you've got this belt rubbing against a comb, and it's rubbing charges onto that metal dome, and if you touch it, then those charges will move into you. And if you're standing on an insulator, like a plastic box or a piece of polystyrene or something like that, those charges will build up and up and up in your body, and the longer you stand on that Van de Graaff generator, the more charges will build up inside you. Why do you imagine this person's hair is standing up like this? Any ideas? Well, if you think about it, every hair on this chap's head is trying to get away from every other hair on his head because they're negatively charged. Each hair is negatively charged. Same charges try to repel each other. Opposites attract, same charges repel. So every part of this person's body, including his hair, is negatively charged and all trying to get away from each other, and that's why your hair stands up on the Van de Graaff generator, as you've seen. So what happens if you touch something that's got a static charge? Well, those charges will move through you. Those charges will try to get down to the ground any way they can. If that means going through your body, then they will, and that will give you a bit of a shock, depending on how much charge is built up, obviously. Now, air is a good insulator, and electricity doesn't generally move through air easily, but if you've got a serious charge, it can leap through the air, and a good example of that is lightning. You might think, well, how is a static charge generated in a cloud? Well, there's a lot of friction going on in a cloud, lots of very strong air currents. You've got ice particles moving upwards and downwards and bouncing off each other and rubbing against each other, and you can get a seriously big static still charge building up in a cloud. And when that cloud goes over something tall, then those charges will jump down through the air and into that object. Let's move on and talk about some uses of static. The first one is a defibrillator. You've seen these in all sort of medical programs on TV. They used to get the heart, restart somebody's heart by putting a sort of weak charge through their body. Another one, we've got the spraying of cars. Now, you could not get that perfect finish on a car using a paintbrush. So what they do is they put the anode, which is the positive terminal, onto the car. So the car's body is plus charged. Then they put the negative terminal onto the paint sprayer, and they spray this fine mist of paint. And being oppositely charged, you've got the tiny little negatively charged paint drops and the positively charged car bodies, and the paint drops, this fine mist of paint sticks to the car body and gives you this perfect finish that, like I said, you could never achieve with a paintbrush. Photocopiers, you can see in this picture here, you've got plus charges forming the letter A there, and you can guess that the toner powder, the black powder, is negatively charged and sticks perfectly to that shape. The next one, we've got a thing called an electrostatic smoke precipitator. This is something that cleans up the smoke that comes out of the say a chimney in a power station or something like that. So as those waste gases and bits of carbon and stuff that would normally cause all sorts of problems goes up, it moves through this sort of metal grid, which gives all those smoke particles a negative charge. So now all my little bits of carbon and bits of rubbish that would go into the atmosphere normally and cause all sorts of problems, they're negatively charged. They go past these positively charged collecting plates and they stick. And every so often they're switched off, they're given a bang, and all those bits of carbon and pollutant and nasties that would go out normally just fall down into these little collecting plates. And that just cleans up the emissions from this power station. So there you go, very, very brief look at what is static and what are some of the uses of it. Now it's your turn to have a go at some questions. Pause the video now, have a go at these, and then the next slide is the answers. Good luck.